1 unsteady, 2 3-dimensional, and then we have constant thermophysical properties, isotropic material. Well, isotropic material is a given, yeah, okay, for this for our analysis for this course. So 239 is complete. Now what happens? I don't know whether last week I think I did a solution perhaps in the Cartesian in the example. Yeah? Now if you look at that, let's look at several boundary conditions that are possible. Yeah, I've shown you the Dirichlet boundary condition where T1, T2 is known, right? So if you have one-dimensional, yeah, so here if you have one-dimensional steady state, so this is, record this. Okay. This is the full heat diffusion equation in three-dimensional, unsteady, constant thermophysical properties for an isotropic material. And as you know in your applied numerical methods, which you have taken, it's impossible to solve such an equation. Same as with your Navier-Stokes, yeah, the momentum equation in the x, y, and z direction. So here you cannot solve this. However, you may be able to solve this if the system is simplified. That means you make further assumptions. Like if it's steady state, then you may cancel that one out. And if you have two-dimensional, yeah, so you may cancel that one out. And then let's say if you have no heat generation, then you cancel that one out. So you just end up with that equal to 0, which is a homogeneous second order differential equation. You can solve this with two boundary conditions. Yeah, the boundary conditions may be Dirichlet form, where the temperatures are set on both surfaces. See, at T is equal to 0 or T is equal, sorry, at X equal to 0 or X equal to some X value is T1. And then at X equal to L or some X2 value, the temperature is T2. You may be able to solve that. It's a Dirichlet boundary condition. The other boundary condition is that you may have temperature here and heat flux here. The heat flux may be 0 in the case for insulated wall. So the heat flux is 0. So if your heat flux is 0, then yeah, so here, if the heat flux is known, yeah, known, so your boundary condition would have been, you follow the Fourier's law. What is the heat flux boundary condition? Yeah, so here we say at X equal to some value, L, yeah, so dt dx, yeah, this is not the one. Let me take that one. It's a bit slow to get it come once, but since once you use it, okay, so it's there. I don't know why. Okay, so we have here d and dx at x some L or x equal to 0 possibly, yeah. So, but don't forget it is what? Because this is minus k is equal to some known value some known value, yeah, yeah. So where Qs is a known value, it could be 0 for insulated wall. Yes. So you get that? If the boundary conditions are given in terms of temperature, you may solve this. It's going to be linear, like this case. Yeah, you will get something like t as a function of x, yeah, will be C1x plus C2, where C1 and C2 are constants of integration. Now, one of them or both of them, boundary conditions are given in terms of heat flux, then you may apply this. where QS is some known value. What is the unit for QS? Well, you see here, it will be in watt per meter squared. Yeah, the unit. You can check this one out. Yeah. Okay. Now, those are some of the boundary conditions, yeah, that are given. But for solid wall, yeah, that is a case for solid wall. Now, what happens if you have two parallel walls with something in between? Yeah, two parallel walls. Then you may have air, like I've done before last week, yeah, and then or vacuum or something else. Okay, so have a look at that. I cannot be showing everything. What happens if you have, let's say, a cylindrical wall? Yeah. So you have something like that, and I'm going to take something from the internet, cylindrical wall.
Aku kau tengok notes dia pun.
Yeah. Just to show an example.
Tak ada tengok note pun lain
This
dengan
is
apa yang
plain
kita dapat.
wall, cylindrical and spherical wall. They look the same if they are only a function of R. You shall see, yeah. So again, yeah, if you have steady state, this is 0. If you have two-dimensional or one-dimensional. One-dimensional
So,
in what?
Dr. Tisham
So
tu dah
in the
correct
Cartesian
choice dah siap.
coordinates,
Member dah
it's
cos
fine
coordinator siap.
because the X, Y, and Z is the same. And now you can relabel it. You can call this Y, you can call this Z, it's the same. You look
Aku
at the
rasa
terms,
masuk
they
chapter 3
all
je tu.
look the same
Test
except for
one.
the letters used. Now, in the cylindrical and spherical coordinates, very important to define one-dimensional in which direction. If it's
Tapi
one-dimensional
aku still
in
tak
the Z,
faham lagi
it's a
sebenarnya ni
pipe.
transfer
Yeah?
ni.
So let's say
Sejujurnya.
you have a pipe.
Aku tak faham lagi tu.
Insert, let me shape. Okay. Insert shapes. Let me say block equation shapes. We have a
Aku
shape.
sebab satu
Okay.
tukar lecturer lah. Tukar lecturer dah.
Okay.
Tak tahu lah kat mana.
Let's see. If you have a cylindrical wall, sorry, a solid
Tapi aku
cylinder,
rasa itu yang Dr.
this is
Tisham
Z, right?
boleh lah. Sebab dia kan nak buat live
This
class
is
lah hari tu.
R. You see my cursor, and theta is in the direction. If
Boleh
you
buat apa
say
dah
it's
kan?
one-dimensional in Z, then this whole
Ya
term
tu.
is 0. Yeah. And you say no heat generation, this is 0.
Haus selamat.
You end up
Boleh
with
kan minum
something
sekarang.
which is the same as that you
Tak hari lepas
obtain
ni
in the
azan lah kan?
Cartesian coordinate.
Tu
Because
lah
you're
tu.
only looking at the
Tengah hari tu
variation
selalu azan aku dengar.
in the Z direction. Here, this
Tengoklah,
direction.
tak pun kalau kau tengok
Yeah.
jam
So
kau,
this one,
kalau jam
if you
jarum
look
kau pukul 7 tu,
sidesway,
kau
yeah,
faham lah.
if you look sidesway, you can see that actually
Pergi ni lah. Puan.
the shape is just like that.
Bazar.
Yeah.
Kau rasa
So Z direction is
Semalam
this
kau
way.
pergi bazar ni.
So it's
aku
important
Putrajaya tu semalam.
one-dimensional in what?
Apa dah?
Putrajaya.
Kau sih. What the fuck?
Best dulu. Tapi aku
Okay,
pergi awal lah
one-dimensional.
sebab ramai nak mampus orang.
If you say
Ya, yang aku tak tahu lah.
one-dimensional
Putrajaya tak nak try lah. Yang Bukit Jalil aku pergi
in
hari tu
R,
memang.
yeah, in R, so you
Kau
would
pergi-
have
kau pergi dalil lah.
this to be 0.
Bukan semalam lah. Semalam aku pergi dekat area rumah aku je. Dekat
And you
Oh.
have
yang lagi Bukit Jalil.
that.
Gini
So
tu
this
baru.
equation would have
Pergi
been for
tempat.
J4
cylinder,
better lah. J4 banyak kat. Tapi
steady
J4
state,
pun beratur tu Pak Ustaz.
one-dimensional
Dia tu,
in
tempat
R,
dia dah kontrol orang dah susah.
constant thermophysical properties. Well, I've taken this one out, yeah. So it should be here.
Ni untuk apa ni mah yang dia cerita ni? Parallel wall lah.
No, okay. This would have been your cylinder. The cylinder also have two versions, solid cylinder or a spherical shell cylinder. But this is the equation for steady state, one-dimensional in R, constant thermophysical properties, no heat generation, isotropic material. So here you have, can you solve this? Yes, you may be able to solve this. Yeah, so this, if it's a solid cylinder, then you have boundary
cylinder
conditions on
dah
the
ada lah.
outer wall. and the one right in the middle would have
Tengok
been
kalau nota Dr. Itishan
dt
memang
dr is
ada
equal
tu.
to 0
Siap-siap
because the
lah.
derivative in the middle of a solid wall for a symmetric, yeah,
Doktor ambillah kami balik
symmetric in
doktor.
theta. So you would have dt dr is equal to 0 right in the middle. For here, dt dr is not 0 in the
Aku rasa
middle
sebab
because
dia
you may
tu,
have something in
sumpah tu.
there. You may have steam,
Sumpah
you
sebab
may
dia
have
kita tak
water,
ada.
chill water, etc. So your boundary condition would have been R1, temperature is given or heat flux is given, and at R2, R outside, temperature is given or heat flux is given, or maybe you have a convective boundary condition. Now let's have a look at the material initial boundary condition, which we have discussed and I've shown you. I want to show you, yes, this one, the Dirichlet boundary condition, and see this one. Yeah, I am going to show you. See, let's see how you may derive that. Cylindrical wall, you see R1, R2. You have this earlier, and you solve it like you learned in your calculus. You first integrate it, you're going to get C1. This dt dr is C1 over R. So it's times 0, d dr is equal to 0. It shouldn't be here. Okay. Okay. So when you multiply the r to the right hand side and then you integrate, you're going to get the first constant of integration. Subsequently, yeah, C1 over R, you integrate the second time, because second order, you're going to get this equation. I mark it with an asterisk. So this is C1, C2 are constants of integration. Yeah. Now you apply the Dirichlet boundary conditions. Let's say it's Dirichlet at R1 is TS1, at R2 is TS2. And you apply that, you have to find C1, C2 in terms of the temperatures on the inner and outer walls. Whichever you start, you see it's the same. Don't worry. Yeah, C1 may be in this form or in this form. Only difference is it's flipped. TS2 minus TS1 and R2 over R1. Same here. Substituting back into the equation, earlier equation, you will get this equation. Which upon rearranging, this is
Tak ada
the
tu.
equation
Asal dia
tak
for
bagi
the
terus semua?
Yang ni dia cari pair tu.
spherical wall. Spherical shell. Spherical because you know TS1,
Tak bagi
TS2.
semua.
Yeah. If it's a
Siap.
solid wall, it's a different matter. Yeah. Solid
Nak suruh
wall,
kau tengok
you have a
ni,
look at it. That means if you have
textbook
solid wall, yeah, you may get the temperature
Hamzah ada kat dalam ni.
on the outer wall, and the derivative in the
Aku
middle
rasa dia
is
tadi
0 if it's a
online.
solid wall. For cylindrical shell, you cannot use the derivative.
Hamzah
in
tukar
the
section
center.
sekejap.
Yeah.
Kau.
So let's have a look for cylindrical wall at steady state, conduction with heat generation with constant K. The heat equations become this.
Tadi tak ada.
Yeah. So here we have what? Steady state, one-dimensional in R, constant thermophysical properties, isotropic material with heat generation. So heat generation is given. Yeah. So you have that. Simplified in this form. Now, because Q is normally given, yeah, K is given, you assume at some constant value, you have to solve this. Yeah, so you solve this in which R dt dr, you get this, and then you end up with this. Yeah, you have C1. I get this. Yeah. So T is how did I get that? R. So R squared over 2 is supposed to be
Selain ni dengan
Quadratic.
quadratization.
Yeah. I didn't get to address this. I was going to look, so we'll skip that. I'll have a look at it again later. It's not the
Tulisan
same
yang warna
as
pink tu,
before. It's supposed to be quadratic. Yeah.
Okay.
So an alternative approach to that of solving the differential equation will be using an energy balance. So you may see the textbook equation 266
Dia
to
16 page
274.
Kita ni
Let
4
me
page je siap.
retrieve the textbook. Yeah.
Bekal.
Jangan ditegur man.
Bapak jauh siap biasa.
Awal main kalau kau berani tanya main.
Meanwhile, think of any
Dah dong
questions you would like to
tiba sangat.
ask.
Dia dengar dia kau main.
Let me see. 266.
Sorry, doh.
Yang dia senyap sekejap tu.
Asal dia tak bagi sama
Looking
dengan
for
dia tu?
266.
Kalau tengok CL apa CL ke CI baru tak ada quiz tu assignment tu patutnya.
Okay, just a moment.
Ya, yang sebelumnya ada quiz.
Tak tahu yang kan dia cakap tak apa tengok lah 20% assignment.
What is
Macam
this?
quiz semua tak ada lah cakap ni.
Dia sekalikan tu. Tahu
I
dia.
am
Tapi
going to do
20% Mat.
something.
Banyak babi.
Step.
Test pun lagi sikit daripada
What is
assignment.
not
Stay
appearing?
pisam tiap minggu tu lah tak ada. Sonok tu. Aku hampir tertipu. Aku terbangun tau tadi tau.
Dia
Tengok WhatsApp.
bodoh sama-sama
Aku
kan.
WhatsApp.
Because I
Aku
want to
dah set alarm tau pukul
close
10
the
lebih
class
tau.
attendance.
Lepas tu aku nak start tidur lah.
So
Lepas tu aku main phone.
late students
babi.
cannot
Mesej je 3-4. Sampai aku tak tidur.
Okay.
Sial.
Now
Aku tengok kan. Aku dah cakap wish tak ada kelas
Okay,
tak. First
let
time.
me
Ya tu.
share with you
Aku pun dah mute tau group tu.
Bodoh lah siap. Aku tak tertidur siap. Betul-betul. Wih babi. Salah group. Aduh. I hope siap.
Sama lah.
So you should have your textbook with you. Let's search for
Textbook lu.
266.
Let's go.
Yunus Cengal.
Emotional damage.
There are many
Mak.
examples in there.
Kau tahu kan? Confirm balik sasa.
So apa yang nak buka ni?
Nak
127.
There. For surface temperature is given also.
Oh.
From
128.
the solid rate of energy
Special
generation within the solid. This is
128
on the
of
surface.
991.
266. See. Energy balance equation 266 to 274. So you have a look at this, 27 up to 274. Yeah.
274.
Yunus
For plain wall with heat generation, cylinder
dah
with heat
kita
generation,
macam kutek,
and
Bai.
sphere with heat generation. Yeah. To look at it again. I got stuck there yesterday. Okay, that covers for the material.
Man, 105 man.
Derivation of the complete heat diffusion equation, boundary condition, and
Dia page
solving
105. Tapi kalau
all
kau
the
buka kat
three
good notes, 128 lah.
equations in 3 different coordinates. Any questions so far
Benar
3 different coordinate. Oh.
on this?
T infinity siap. Apa?
no, doktor.
Allah.
Excuse me.
Siapa? Siapa tanya soalan?
I was going to print the name,
Bodoh dia anak
but I
bodoh.
didn't manage even to get to the internet to access your latest aims.
Jangan banyak alasan. Betul.
I know
Can you
here
hear me?
Navindran and Prem, are you here?
Dia ingat tu je tu.
Okay,
Best student sial.
Doctor, can you hear us?
Weh, sekarang nak.
Prem is here.
Penat.
My mic is not so loud.
Prem tag siap.
Is Navindran here?
Masalah panggil nama aku buta ni.
Prem tag siap apaan?
So, attendant.
Apa?
Navindran is not here.
Prem
Okay.
tags.
Navindra dengan Prime ni macam akib
Ifa.
dalam
Oh.
kalik dalam mechatronics.
Not sure about the others because
I
students, wandering students have returned and yet
Hai.
Student, monthly student.
wondering
Enggak puas hati.
UTM is still 26 students.
tak puas hati panggil lah.
Haven't
Oh,
updated yet.
26 je tinggal daripada 60
No
itu.
questions?
Kit siap.
Yes?
For the cylindrical coordinate, we consider in z direction, we consider in radius direction and theta direction. How do we come to the conclusion to consider the directions actually?
Okay. Let's have a look at this.
Now,
Tapi kalau Tisha cakap memang
We
kita
have to look at
pakai
the.
1D mostly kan.
Let's try this. Let's
tengok
unblend
dia
this.
1D kat arah mana lah.
Okay.
Cakap
And this.
kalau
Okay, this
Z
is the one.
direction.
whether it's cylindrical or
Transfer.
spherical. Let's have a look at cylindrical.
Kau tengok video
Sorry,
edition yang
doctor.
baru
The
tu
book
semua.
is still showing.
Bukan
Oh,
last
you
dia bagi
haven't seen
video
my
hari
this.
tu.
I'm not sharing this yet.
Yelah
Okay,
yang
share
tu kau
this.
tengok kita dengar.
Sorry about that.
Tengok.
Okay.
Okay.
So this one. This is a solid wall.
Aku rasa time
We are
cuti aku
talking
tengok
here. So
notification
here.
punya video lah.
Okay, let me
Adin
see.
siap.
Tapi dah habis kan.
Solid
Tak ada guna.
cylinder. Okay, and
Baik,
I'm not
Doreen.
recording this.
6 kredit
Hai,
siap.
I just recorded the lecture.
6 kredit
just
tu
now.
subjek kau.
Okay, so listen carefully.
Ya doh.
So solid cylinder. Steady
Bodoh,
state.
okey
Most
je
of
tu
the
campur
applications, most of the heat transfer problem we
Dah kau
have
nak
Lain
is in
sial.
steady state for now.
dah kau nak
Later
dengan
we
doktor
look
ni.
into transient. In the beginning, you assume
Mana
is
nak faham
what are
sangat.
the assumptions? We
Otak
have
pun tak nak bagi.
assume here
Transient tu apa tu?
steady state. Yes.
Transient apa?
What else?
Tak kali dengar.
Constant
Kau ni
thermal
yang
Unsteady.
physical
ah,
properties. It's very
So-
important,
so-
yeah,
so-
to
sorry,
have
sorry.
this before you
Bandai,
begin your heat transfer analysis.
Sorry.
What else? Maybe you can say isotropic material. Because your K is all the same, shape all the same. Constant thermophysical properties. That would mean actually not that
Zan
equation.
email.
You should take a simpler one. What is the simpler one?
Dia punya notes dah repair by bapak.
Okay.
Tak ajak by repair.
apa yang dia tak nak bagi yang 14 page ni? Kenapa dia bagi kita yang
That's a
Oh,
full
belum.
one.
satu
Dah repair
Dua,
lah tu. Dia buat
I have
baru.
to take out the
empat,
K.
empat.
Remember,
Ini
it's
unlock
constant
je kan?
thermophysical properties, people. So K is taken out. Right. And then here, I hate this sharing mode.
Quotation
you know,
Isma pun
because
tak password kat dia
then-
punya note.
Dia punya
cannot-
sulit tu.
type.
PNC bodoh dia punya.
What was it? I was going to put, oh, okay, the fraction. Yeah.
Private
So,
and confidential bro. Cannot share.
very difficult when you are doing it here. So you
Baik,
have K,
sekarang ramai
right,
anak
there,
notes dia.
which is thermal diffusivity, right? So that would have been, is there a term there, diffusivity here? There, that would have been 1 over lambda or no?
Benda lah saya
No,
say
leave it
that
there.
acid
And
like ke
here,
apa.
Beli Xiaomi tu. Xiaomi tu baik tu.
would have been that. Okay, so that's actually the
Yeah.
full equation. Steady state,
Tapi,
constant
okay,
thermophysical
aku say.
properties. Otherwise, you will not be able to take out the K out of the brackets. Isotropic material, all the K's are constants, yeah. And then we
Dah
have
sampai
there
tu,
what
Mai.
else?
Jagi tu.
There's heat generation. So this
Jagi
is where
Baiklah.
you start
Oi,
Kau ni apa,
to
Man?
consider the actual
Dia lah.
problem.
Memang beli
Ah.
boba.
I will show examples
Apa?
past
Siapa
assessment
K tu?
question
Belagak
later if we have
siap,
time. But
Man.
right now, this is where you have to consider each problem
Macam mana,
individually. So if there is nothing, there's no heat
Tapi apa
generation,
Q
then
tu ada
you
K
can
kat?
put no heat no heat
Aku tak tahu
generation.
tu. Padahal dia
Apa
sebelum ni
Q?
tak ada kan.
What is so
K tu.
I
Apa
know
Q tu
it's
ada K kat? What the fuck?
Yes. No heat generation. What else?
Yang puasa kan.
So you have one
What is
dimensional
this? What is this?
Dimension. Yelah.
in where?
Macam tu eh.
Tapi kau kena pindah semua ni baru ber-K.
Then you
Baru
have
boleh
to
buat
consider. Sometimes the heat transfer,
Asal dia pindah
the
sebelah tu
boundary
at the
condition
first
is
place?
given at R is equal to something. Yeah, at R is equal to something.
Dia bahagilah. Dia bukan
So when it
benda.
says
Oh,
that
ya,
R
dia
is equal to
bagi.
something,
Asal dia
already
bagi?
is one dimensional in R.
Tak tahu.
Oh,
It's
kerana semua ada
symmetric.
K kan. Betul.
Asal dia bagi lah?
Symmetric. So you have here
Okay.
Tak.
Korang ada
Secara
tip apa tak?
Overthinking
symmetric
je.
with respect to the
Contoh sikit-sikit je tu.
axis.
Contoh kat mana tu?
Nota
Bukan
yang
dia lah.
Nota
ke
dia
bawah.
This is symmetric. At any angle,
Yalah.
at R is equal to R1, there's a
Dia asyik dia
boundary
bagi K
condition.
tu.
So if you look
Sebab
at it that
isotropic
way,
material ke?
see like
Tak
this.
tahu
If
aduh.
you look at it this way, so that
Ke sebab
means
constant thermophysical tu.
Kalau
Nak
steady,
tunggu, Man.
DT kosong
at
kan.
this R,
Kalau sedia belah kanan tu
regardless
kosong.
of the angle, it's the same temperature. So it's
Tengok
definitely
konteks
one
moment.
dimensional in R. And
Hah?
along the
Konteks book.
cylinder is the same
Tengok apa?
boundary conditions on the
Textbook.
wall. So you can see one
Facebook.
dimensional in R.
Textbook
Apa
bodoh.
So we have
Facebook
this,
nak.
Facebook
Benda sial
and we
Facebook.
have this,
Tak kau
and
mana
we
aku
have
tahu
no
habis.
heat generation.
Facebook tiba-tiba.
So we have this.
Anet kau yang
Then
tak
you
dengar
solve it.
babi.
Udah FB siap. Bawang babi.
Did I answer your question, Pran?
Oh, heat
Okay.
generation yang Q dot.
Yes, doctor. And one more, doctor. If
One more,
let's
doctor.
say this is the problem and the
Jangan
heat
malu.
generation, sorry, the heat transfer is happening in the Z axis. So if we will consider the Z and remove the DR and E theta.
Yes,
Okay.
because it's impossible to solve in two-dimensional, not in
Okay.
heat transfer. Okay, there are problems
No,
where
1D
it's
je lah.
varying in theta. It's a possible. One example is I have given
Variations, yeah.
before. It's my kind of question.
Tidur dah,
Something out of
dah
the
bubar
box.
siap.
Let's say if you
Baby,
have
you light up my way.
furnace.
Siap.
Furnace, let's say, do we have here?
Ah,
Kalau
there
dia
is
kata 1D in Z direction,
Quarter
T
circle.
apa?
You don't have a quarter
V
circle.
dengan R tu lah kita potong kan.
Quarter circle. Maybe like that. It's almost like a quarter, is it? Yeah, maybe. You just assume this is, no, that's bad. Let me find online.
Okay, quiz nanti apa saya nak tanya? Apa pun tak faham lagi ni.
I hate this, you know.
Aku harap dia bagi quiz kat Google Docs je lah.
It's a moment,
e-learning
please,
though.
It's a bit difficult because I'm
multiple
trying to
choice
go
question
online
eh.
unless I stop sharing.
Sini lah.
There. Then I can go and search online because what is this? See, just a moment. I'm looking for image of a quarter circle. Yeah, okay. So is this? I cannot copy the image.
Sinetron style siap.
Where is this?
Hello.
Style tu kau.
Sorry, I'm still searching.
Nak sorry apa mana
I
boleh?
want to copy an image.
Sorry ya.
Okay. Okay. Let me.
Nak sorry apa?
Okay.
Tak kita orang buat silap ke apa tak boleh pula.
Okay.
I will not
Pengoyakan
entertain this,
siap.
doctor.
Sebab
I will not
So you
entertain
see
sebab
here?
this.
section 1 siap.
It's a quarter.
Cerita dia
Let's say
belum
it's a
pukul 9
furnace
lagi tau budak-budak
and
dia.
it extends.
Tak.
It extends in the Z direction. Yeah.
Masalah
This is
nak.
R. So the furnace may have a boundary condition where the floor is heated up.
Late siap.
Floor is heated up, and the vertical is probably different temperature.
Kan budak tu masuk
Maybe
lambat.
different
Memang tak
temperature.
boleh
Let's say
pakai
it's
sebenarnya.
this one. This
Ah,
is
tengok Munaf
TS1,
kan?
this is TS2. And you
Belum
can
lagi
see
dah.
here, this angle is what? Pi over 2.
Baik doh.
And this angle is pi. Correct? And at all the R's, the
Asal
temperature
dah
is the
tiba
same. At R here,
dengar
R
dua
here,
sound
R
ni.
here, all the way R,
Kenapa
the
dia
temperature
babi
is
lah.
TS1. Here at all the R here, the temperature is TS2. Maybe this is insulated. So in this case, the boundary condition will be at theta is equal to say pi over 2. You have TS1. At theta is equal to pi TS2, and it's one dimensional in theta. Yeah, because along the furnace, I have given this before. I'll try to check it out and share with you some example. So this is one such example. Variation in theta only. So you would have this term 0, this term 0, no heat generation, this is steady state, and you have this term. And the way you solve it is quite similar to that, but you have learned that in your calculus. Here is to apply that. So mathematics are used to solve real physical problems.
Semua subjek pula nak pakai kat transfer
All the
ni.
WhatsApp are coming in. Any question on this?
Numerical
Same
lah,
with the
fluid
spherical
lah. Semua lah.
coordinates,
Calculus lah.
Move this.
Tapi transfer ni legit more to fluid doh. Tengok balik.
Right. So let's
Ya
have a look
tu
at the
tak masuk
spherical
gear termo dia.
coordinates. This is spherical conduction. No, this is not spherical. So let's see. So Control C.
Bagilah Dr. Note sini. Oh.
Hmm.
Betul lah.
Siapa berani try minta tu?
Please.
Aku tak berani lah.
Dah goy ya.
Memang goy tu. Dulu minta kat Dr. Yati boleh sound man.
It's hard, yeah.
Tapi lepas tu dia
That
bagi
is
tu.
why I
Ya
prefer
tu.
face to face.
Bagi je budak-budak
Okay,
yang
that's
share.
one. Yeah. It's a layout. I want it narrow. So still cannot.
Dah pencen ke?
Sorry.
Belum maksudnya. Macam dah kan?
Ya.
So let's have a look
Tahu.
again at this cylinder. If it's a solid cylinder, yeah, the derivative in the middle is zero.
Macam nak tadi IR
As
ni
you know,
kan?
it's item.
Oh, sekejap. Aku rasa
Majority, yeah.
belum.
The
Oh, itu
is
daripada
zero
kita
here
bawa semester kita
because
kan?
it's symmetric. Yeah. They only give you one boundary condition
Oh.
explicitly. Yeah, explicitly. Now, if it's a shell, yeah, what's this?
Tak boleh doktor. Doktor tak boleh buat macam tu.
This no fill.
Dia nak buat lubang.
I'm not talking about
Itu.
that. Okay, never mind. Okay, so this is fill.
Tak ada nanti dia
It's
boleh
not.
sama.
Okay. If it's a shell, then here may be hot water, maybe chill water, maybe a refrigerant, whatever. So you have a
Dalam
boundary
lubang
condition here on the
Hmm.
inner R and the outer R. Okay.
Hmm.
If it's a
Dia
solid
buat putih je.
cylinder, you may have a boundary condition at the outer R that is explicitly given, and right at the center you may use the R d theta is equal to
Zero.
Okay. And you may solve because second order you need two boundary conditions. For now, everything is steady state. Yeah. If you have the heat generation, yeah, it's also given in your examples. Let's see. Am I sharing this one? Wait, okay, I'm sharing. Yeah. Look at this. Conduction with heat generation in a solid. Let's look at how heat is being generated. Just now we looked at how the conduction diffusion equation, the heat diffusion equation is solved. Yeah. Let's look at the part 2.
Wah, ini 4-4
The thermal energy generation in a material may be due to conversion from other forms of energy.
Doktor
It
ni
could
rasa
be
lambat
nuclear
gila habis
reaction,
38
like
minit siap.
neutron deceleration
Masya
or acceleration, gamma rays.
Allah.
The heat generation may be due to chemical reaction,
Ya Allah, kau
exothermic,
kuatkanlah aku
endothermic, which
di
is
bulan
negative,
Ramadan ni,
yeah,
ya Allah.
endothermic. Exothermic is giving out energy, endothermic is absorbing energy. And it could be electrical resistant wire, which is quite common, yeah, in examples in heat transfer. Now, the volumetric rate at which energy is generated by an electrical resistance wire, yeah, is normally given in a known
Masuk
quantity,
elektrik pula. No.
yeah, unless
Subjek nak masuk ni.
the current and the resistance is given. Okay. So, how can you imagine the temperature profile in there? Remember, this is, let's say we are looking here at the plain wall. Plain wall. Here we have a fluid at temperature T infinity 1 with convective heat transfer coefficient H1, convection because it's fluid, and the T surface Ts1. On the other side, we have another fluid, yeah, at temperature T infinity 2 with convective heat transfer coefficient H2. Now, this side of the wall and that side may have the same fluid. If that is the case, you may have you still have a different convective because sometimes here is faster, H is higher, forced convection. Maybe this side is natural. Convective heat transfer coefficient for natural convection is lower than that of forced convection. Yeah. So now If it's surrounded by the same material, then perhaps you may have H1 equal to H2. The temperature also may be the same. But let's look at the general problem of heat transfer. Let's say it's different. So here we have heat generation, somewhere there.
Oh ni ada
Look
glow
at the
dan
temperature
go.
profile, it's not symmetric. So this is called asymmetrical boundary condition. Say at here they use minus L. You can say x equal to 0 here. X equal to L or 2L or whatever. Just make sure you know what is the thickness of your plane wall. And you see here at this particular wall, call it X1, we have TS1. And at this particular wall, X2, we have TS2. Yeah, if it's known. You can have convective boundary condition as well. Here, if it's symmetric, if it's symmetrical boundary condition, you see here, it's symmetric. Look, this is convective heat transfer coefficient H, same as H. T infinity is symmetrical. Yeah, so the volumetric generation is generally volumetric, so it's symmetrical. Assume per unit volume, everywhere is the same. Everywhere is the same, but because the T infinity 1 is different from T infinity 2, H1 is not the same as H2, you have asymmetrical heat pattern. Here, if you look at adiabatic surface at mid-plane, or it's just a wall, mid-plane, so you can have a look at that. For plane wall at steady state conduction with heat generation with constant K, the heat equation in Cartesian becomes that, integrating with boundary conditions, get that, and you can look at example 219. See, let me share 219. So your textbook is very comprehensive. You'll be surprised that some of them may be used to generate other questions. So let me share this one. Share content, this one. Okay, this is 219. Yeah, quite explanatory. Schematic, for example, 219. Consider a long resistance wire of radius R1, so it's a wire. 0.2 centimeter and thermal conductivity 15 watts per meter per Kelvin. Most of these examples, the thermal conductivity is provided.
Man, sebab aku
Now,
hantar
in your
lambat.
assessment,
Kak Gula dia tak nak
whether it's a
bagi, baik.
quiz, homework, or test, exam,
Dah reply.
you may
Dia tak
need
nak bagi
to
tahu pun
search
aku
for
dapat
the
kata.
thermal conductivity at
Kau tanya
some
ke?
fixed
Tak tanya
temperature,
pun.
which you have to assume at the average
Lama
temperature.
betul kan dah
Here
kira
we
reject
have
ke apa
here
tu.
notice
Tak, aku
heat
rasa
generation
dia
50
so
watt
aku
per
bagi lambat lah.
centimeter squared.
So member kau.
Yeah.
Dia tak reply
There.
terus lah.
So
Siap,
it's
siap.
in a 0.5 centimeter thick layer ceramic. So that means thick layer, the radius, the outer radius is
Particular betul kan
0.7.
Tok Gula.
So mean R2, because the thickness of
Benda
the
aku dah
ceramic
email
is
dia sekali cakap
0.5.
apa aku boleh bagi hari
Let me
Ahad.
point out that you have to be careful when
Tapi yang post lah.
solving heat transfer problem. Make sure you understand that radius, diameter, thickness, thickness is where R1 plus the thickness will give you R2. Yeah. So here is already shown. T wire is T1. L, sorry. It's shown. So I don't have to go through here. You may go through them yourself. You get the temperature. Now once you get the temperature, here 149.4, make sure you think whether it makes sense or not. Yeah. Of the wire,
Oh, yang tahu dia make
this is at
sense
x equal to 0, 152 points. Whether it's the
Tahu.
order of magnitude, whether it's positive or negative, makes sense or not before you proceed to the next question. Okay. That's given. Then, obtain Tx for Ts1 equal to Ts2. Let's have a look at this. This is additional. Now, what happens if Ts1 is equal to Ts2? Then this part would have been 0. Correct? And you end up with just the rest of the term. Where does the maximum temperature occur for the above case? Why am I having
Huh?
Tx1, Tx2? Okay. So temperature on both surfaces are the same.
Allah, baru 45 minit Allah.
See? Both sides of the plane wall, the temperature is
Sejam
the
tak
same,
habis.
this term is 0. Where do you find the maximum temperature in the plane wall? Azlin, are you here?
Oh, Syah.
Yes. You suggest. Where do you think the maximum temperature will occur in the plane wall?
Nama dia tak ada kan? Like,
Inside.
Aduh, aku dah nama panjang siap.
Wait, let's see
Bagi nama
when you
bapak,
get a
eh.
plane wall.
Mana main nama kau?
Give you a plane wall. Okay. Let's say you have a plane wall. Yeah.
Luar
So
lah.
you have
Luar
TS1 on this side, TS2 on this side. Where does the maximum temperature occur for this with the heat generation?
Middle lah.
That's right.
Top.
Kau bila siap?
PS2.
Tak lah bodoh sebab top
Ah?
kan. Kan yang sejuk-sejuk semua
PS2?
pergi bawah,
No.
top pergi atas.
Baik Doris.
Yang panas pergi atas. Tak tahu lah.
Oh,
Dia yang top
Okay,
betul kat
okay.
tengah.
but you have heat generation inside. TS2 may be higher than TS1. Let's have a look here.
TOP top.
So we have TS1 here. You see, it's a bit difficult. So you have TS2 here.
CS
Yeah.
tu.
And we have here a thickness of say L thickness.
Memang CS tu dua-dua
Actually,
Ah.
let's
TS2.
see.
CS tu ada ke?
I don't
Tak,
want
Betul
to
TS2
duduk.
kan?
Memang CS1.
budak. Okay.
Ha?
Let's see. You have I cannot see there. Insert a text box inside there. Sorry, it's a bit slow.
Chase ya.
Yeah.
Kalau TS sama dengan TS dah
Okay.
macam gambar kedua tu ah.
Let's say I have a Q.
Kan?
Patutnya ni TS1 kau
No
sebelah kiri.
flux there.
Kan gambar kedua tu TS sama kan kiri kanan. Tapi dia punya T infinity sama tak tahu lah.
See that? Okay. So I have a known is a volumetric. Okay.
Doktor tengah
One
practice word sekali dua
shape
dalam.
outline. Okay.
Oh,
So
pro
that,
word.
that kind of problem. This equation. One dimensional in X,
Are
steady
you
state,
computer literate or not? Big.
constant thermophysical
Equation,
properties,
bitches.
isotropic material wall with heat generation. So that kind, we end up with
Panjang-panjang man formula subjek ni.
this equation.
Kau tahu
yeah?
aku baca
We had this.
junior engineer apa? I impact apa tu aku lupa lah yang aku baca lah. Dia
Apa
cakap
kota ni eh?
bukan. Ni yang time kita cari English punya
Oh,
dalam. Atau aku baca lah, dia cakap fresh graduate
So we had that one. And
dia
then
alu-alukan lah.
we solve.
Lepas tu tiba dia punya
we got
requirement
this.
1 year of experience. What the fuck?
This is
bodoh
example
macam tu.
219. But I am
Sumpah
adding
terbanggang.
additional
Experience apa
question.
kerja
Anybody
7D?
would like to
On
help
lah.
Azlin?
Azif,
Izol, are you here?
Izul.
Izul Irfan.
Dia tengok nama satu-satu je tu.
Budak
Ya
ni
Allah.
budak first dah masuk ni.
Where does the maximum temperature occur?
Top,
It cannot be TS2 because heat is being
Oh, dia antara-
generated inside the wall.
Dia top middle lah.
If there is no heat generated,
So what
then
the
yes,
middle?
maximum will be
Tak, aku fikir top.
sorry.
Aku fikir dia top je.
Okay, this is one.
Sebab
Maximum will be
heat-
TS1.
heat yang
TS1 is higher than TS2.
panas dia selalu pergi ke atas kan. Yang bawah
Oh.
kan.
Kau sejuk siap.
Macam kalau duduk naik kan nampak kan.
TS1 is higher than
Allah sebab
TS2.
angin
You
apa?
know, it's
hot
not
air dia
linear
less
why?
than
Because heat is
dia
being
kan kat
generated.
atas.
Yeah?
Less the
The temperature
Less
profile
than.
will not be linear. If this is 0, then it's linear. But you have heat generation. So the temperature profile, if you were asked to sketch, sometimes you'll be asked to sketch, it will not be linear. It will be parabolic.
Kalau ada QS.
Because why? You see x square here? It's a parabola. It's a second order
Ni formula
polynomial.
apa?
So it's not a linear. Anyone would like to try where the maximum or perhaps inside the wall?
TS1 lagi besar
inside
ke
the wall,
TS1 sama
Azli.
tu?
But where? Or how can we determine?
Inside the wall. Kiri kanan. X.
In the middle? But I said TS1 is greater than TS2. It's not symmetrical.
TS1 lagi besar.
Yeah. It
Tak,
is
Ya, tu.
symmetrical.
Tengah.
Yes.
Dekat parabolik kan
TS
macam tu kalau kau tengok.
As it's in the
Atas tu
middle.
apa ni? Tengah.
But if it's not the same,
How far is this?
there's one sure way to determine. It may happen in the middle. You learn it in calculus. Where do you determine the maximum? How do you determine the maximum?
Macam
Gradient.
numerical yang tajuk ujung babi.
Equal to 0 lah.
Yes, you take the derivative. Correct. So that means you have to take the derivative of this
L
equation,
bagi 2 lah.
let it equal to 0, and find where x such that the derivative is 0. Correct. You may try that. Yeah?
Sampai dia panggil Azlin, kau panggil Faris, silap lah dia.
So dt dx, this term will be a constant. This term will be 0. This one will have minus 2x multiplied by this. Let equal to 0 and find the value of
Kena
x.
kosongkan mana dia kata?
DTDS kan?
Okay.
DTX.
Can you do that?
Macam
Or would you
kita
like
buat
to do that
apa
here?
yang macam
It's
dulu
too much to do it here.
equation to 0.
Hmm?
Differentiate jadi 0.
Oh,
So
sebelum
if you
integrate
want
tu
that,
lah.
You have to
Kan,
take
sebelum
this dt
sebelum jadi
dx
formula
equal
tu
to
lah.
0. Yeah.
Ha.
So
Maksudnya
basically,
DTDX lah kan?
Sebab formula ni kan dia dah integrate kan?
Hmm.
to
Mak
get
rasa macam tengah
the
mu siap.
location of the maximum temperature. Yeah. Take the derivative of t with respect to
Respect.
x and let that equal 0. Then find x such that the derivative is 0. That's all. You know, you have y is equal to x squared plus something, and then you take dy dx equal to 0, fine. So that is, I'm not going to show
TS1
that.
lebih besar dari TS2 je kan? Macam ni.
Anything else?
You could
Can you
nampak gaya
proceed
dia
with
punya
that?
maksud dia tu.
You're already in third year, should be able to do. If you have problem, yes, you may ask me.
Take
You
five,
may
take
ask me in the group. Maybe some other students will is also having the same problem. Yeah. So perhaps I can give an
Dah
example.
selama.
Okay. Now I would like to take 5 minutes off for now before we proceed.
Respect
So
lah tu.
5 minutes, we'll meet again, or maybe 5
Left
minutes,
dulu.
58. Yeah, 9:58 around that. Okay.
10 lah kata.
You may
Wait.
reapply for second round if 2 weeks
No.
have passed from sending the application to company and there is still
You
not
don't want to
unsolved.
stop?
Hey, no.